Today, to form a black hole, all you need is to compress a certain amount of mass, matter, and energy into a given volume of space-time. You then define an event horizon, a kind of gravitational trap. That is the black hole, and we don't know what lies at its core. It could be a singularity, a non-singularity, a wormhole, anything. All these strange things are theoretically possible, but a black hole is the event horizon.
But what do you think actually happens to the information that falls into a black hole? Is it lost immediately? Is it stored somewhere? Can it be recovered? And maybe you could also explain what information means in this context. What exactly does that term refer to?
So, we've now come to a pivotal episode in the history of black hole theory, centered around what became known as the information paradox. It originally stemmed from a fundamental law governing the evolution of black holes, at first proposed as a hypothesis, but later proven. It was first formulated in a rather picturesque way by John Archibald Wheeler, who famously said, "A black hole has no hair." It means that during the formation of a black hole, nearly all the information about the matter that contributed to its creation is lost. Typically, billions and billions of bits of information. Things like shape, composition, and a whole range of other properties are swallowed up by the black hole, and only three quantities remain. Its mass, what's called the angular momentum, which is related to the black hole's rotation, and possibly its total electric charge. So the idea that a black hole has no hair meant that once a black hole has formed and reached equilibrium, meaning it's no longer interacting with anything, it is completely defined and fully described by just three parameters. Paradoxically, that made it the simplest object in physics. Let's take something simple, say a lump of sugar. If you wanted to describe it in full detail, you'd need billions of parameters. Sugar can be white, it can be brown, it can be cube-shaped. It has a specific form, it has an atomic composition, and so on. That's billions of parameters. And yet here you have an object, a black hole, that's described with just three parameters. Then in reality, we come to understand that while electric charge may theoretically exist, but in practice, it doesn't. In other words, when a black hole forms, it is electrically neutral. This means that the typical black hole in the universe is described by the Kerr solution, also known as a rotating black hole characterized by two parameters, mass and angular momentum. In other words, the black hole has absorbed an enormous amount of information. Well, that's good. It means that all configurations of matter outside the black hole have been absorbed by it. Thus, a classical black hole is essentially an information trap. This was the concept in the early 1970s. A trap for information.